Hello, my name is Patricia Foley, and we will be going over ICP-2 for the cybersecurity class. So there's three different parts to this ICP. The first part is really focused on using not only the training data to train the network, but also a validation set to see how well the network actually performs. We'll go over overfitting. The second part for this ICP, we're going to discuss the saving and loading of a network. And the last part of the ICP, it deals with using your own data and how do you load that and run it through a network. So for part one, let's get started. And so what we're doing in this first step is just loading the libraries and loading the data. So in this case, we set a transform for the data, which just normalizes the data. And then we're going to have both a training set and also the test set as well. And then the second part is actually building this network. And as of right now, we're not going to have any dropout layers, so we'll just have this simple network of 4 different fully connected layers as our network. The next step is to actually load the model, and what we're doing here is just taking an image and showing that, oh yes, we do have 10 categories, and we do have 64 different images in the test set. So the next step is to look at the actual probability and to show like the classes for each image that the model has selected. So in this case, we're taking the first part of the images, and it classified the first one as 3, class 4, 3, 3, 4, and so forth. The next part is I'm just going to run this guy, and again, it's looking at the top class for a particular image. The next step is the accuracy, and as you can tell, the accuracy is very, very low. This is to be expected, just because we haven't actually trained our model yet. So the next step is to actually train the actual model. And so what we do is we load that specific model, we set the type of loss we're looking for, and we're also looking, we set an optimizer as well. In this case, for this demonstration, I'm going to only run it for 2 epochs, but this is the training portion of this network. So this is where it propagates back through the network and updates the weights accordingly. In addition to that, though, this is the new part for this ICP, is we're actually going to be looking at a validation set. And so even though your training accuracy can get fairly low, the most important part is to actually test your training or your model on validation images or whatever your data is, to see how accurate your model is. So we'll let this run. It's going to take a little bit for it to run. So as you can see right here, so the training loss is only about 0.5, which is great. The test loss is also fairly low, so the test accuracy is fairly high, and that's what you're wanting for the model. So the reason why you want the accuracy for the validation or the test set to be higher is because it's showing that your model isn't actually overfit. So we're done running that guy. So then the next part is talking about overfitting. So when you train your model, there's something called overfitting, where it basically learns the training data too well. And you can see that when you have a very low loss in the training, but then when you actually test it on images or your data that hasn't actually been used in the training process, the loss is great. It's very high. So that means that your model is actually overfit. So in this case, to help prevent overfitting, one way to do that is use dropout layers. So this prevents certain nodes and everything like that to be overtrained, and it just randomly selects what it drops out each time. It's not consistent with what it decides to drop out. So in this case, to add the dropout layer, you just do self.dropout, and it's looking for that probability of 0.2. So again, we're just going to run it for 2 epochs and just see what happens. So in this case, our accuracy looks like it's starting out lower than what we had previously, and in this case, it's not necessarily surprising that it is, just because of the data set that we're using and the simple network that we have. Using dropout layers might not necessarily help in this case. So yeah, so we ended up with a test accuracy actually lower than what we had without using dropouts. In general, like in a more complex system, using dropout is a way to prevent overfitting. And then the next thing is just we're just showing an image. In this case, we ended up getting a shoe, and it shows just the probability that it actually is a sneaker. In this case, it looks like it has a probability of 1, and so the model did accurately classify that image as a sneaker. So the second part is we're just going to go over the saving and loading of models. So again, let's just load the different libraries that we need. The second part is to actually load the data set. We're using the same data set as before, and it's the Fashion MNIST data set that's available with PyTorch. Again, we're going to have the training and test. This step just shows one particular image. In this case, it kind of looks like a dress maybe. So then the next thing is just building a model and setting the criterion, and also the loss function, and then also the optimizer for updating the weights. So the next step is we're going to train that model. This is going to take a little bit. Alright, so it's done training and also testing the model. And so the next step is just to kind of show what the model actually is. So in this network we have 3 different layers, and we do have a dropout with a probability of 0.5. This also is the dictionary that shows, the hidden layer weights and the biases. That for layer 1, or technically 0 is the input, 1, 2, and the output weights and biases, which is indicated here. So the simplest way to actually save the model is just using this .save function. And to load it, again, you want to use, we'll need to make sure that the weights, the biases, all those are actually imported as well. And you'll see if we don't do that, we'll actually get an error down below. And so what we're doing when we're saving this, we're actually saving it to a specific path. And then when we load it, we're just loading it from this specific path. And then to load it with those specific weights and biases, you just use this load state dictionary. So this in particular is what will actually throw the error, because what we're doing here is, so say you want to load this network, but you want to change it a little bit. So as you can see up here, we had 784, but then the output features is 512, and so we just want to change up how everything is connected, and so we'll actually get this error that occurs. So to do that, then what we need to do is change this checkpoint dictionary. So we say 784 and what we want to change it to, and save it accordingly. So in this case, we'll just create this quick function, and helps us to create this new network that we wanted to create. So in this case, we have that 400 and 200 as we indicated up above. So the last part of this ICP is how do you load your own data that's not readily available through PyTorch. So in this case, we're just using a data set that had pictures of dogs and pictures of cats. So one thing to note is what I ended up doing was taking these images and placing it in a specific folder that said dogs and cats, both in the testing and training folders. But as always, let's start off by importing all of the libraries that we need. And then the next part is to actually load the data. So this is where I saved my images. So this is just the generic folder directory. And then within this directory, I had a training folder and a testing folder. And based on that, it goes in and it looks for, and within this train and within this test, there's an additional folder called dogs and an additional folder called cats, and both of those guys. So let's go ahead and load both the training and the test sets. And then what we wanted to show was just that we actually did load the data correctly, and in this case we just kind of created a mosaic of a variety of images. The next part is to actually add a transform to the images, because just because you load them, you need to reshape them to the proper size that you need, and also center them. This will help when you're actually training and validating your network. So let's go ahead and do that. And it looks like I have a bit of an error. Let's see. Well, for some reason that's causing me an error. It shouldn't, because it's exactly this guy up here, and now that's also causing an error. Interesting. But that didn't cause an error earlier, so I'm not quite sure why all of a sudden that is. But as you can see, I still have the data, I have the test and everything like that. They've been resized to the same shape, to the same size. As you can see, though, it looks like some of the resizing kind of cropped off some of the key characteristics that would be used to identify this cat versus a dog. The next part is to actually train the data, or train the network, and also test. So we're just going to run through that really quickly, and in this case we're only going to do 2 epochs. Alright, so we're not going to wait for this to finish training and testing, but when I ended up running this earlier, it is still going here. It ended up being pretty low accuracy, which is to be expected because I just took, instead of building a network, I just took a pre-trained model of the AlexNet and set it to pre-trained. So we're actually, even though it's pre-trained, since I didn't drop off the output layer, I'm technically actually not retraining this network. So the accuracy is about 50%, which is to be expected, since it's basically just guessing which class it is. So as you can see, it's actually done training here, and then it's just going to evaluate the model. So yeah, so it's about 50%. So thank you for listening.